Now here's a little bit about a very interesting function called the unit step function, sometimes called the Heaviside function, and I won't call it the one step, but it gives us a way to make a piecewise defined function but not have to use well, be able to write it all in one line as if it's all one function, and it is. And sometimes it's called the Heaviside function, named for Oliver's Heaviside. But generally, the function u of t, it's like this. If a is positive, u of t is 1. And if a is negative, u of t is 0. Actually, I should say if u is non-negative, u of t is 1. If u is negative, then u of t is 0. But it's translated a little bit when we say u of t minus a, because we could say u of t minus a is 0 if t is between 0 and a, and it's 1 if t is greater than or equal to a. So that's called the unit step function or the Heaviside function, and I think you can probably see why it's called that. So often used to help define piecewise defined functions, and it translates, as this says, translates the t-axis by a unit. So let's use the unit step function to define this piecewise function. F of t is either g of t if t is between 0 and a, or h of t if t is greater than or equal to a. So we'd start off by saying, well, this function is g of t until t reaches a, but once t reaches a, we want it to be 0. So what we do, we subtract g of t times this unit step function t minus a, because once t reaches a, this will be 1. So we're saying g of t minus g of t, which goes away. So this function from here will be g of t up until the time when t reaches a, and then this part of it will be 0. Now, what about the other part? Well, that will be h of t times u of t minus a, which is 0 until we reach a, so it'll be 0. This part will be 0 until we reach a, so then it would be u of t minus a.
Fascinating.
Times h of t. So then once we get to a, this will be 1 times h of t and 0 times g of t. Actually, it'll be 1 times this g of t, but then it'll be subtracted from this g of t, so ultimately this part will be 0 once we reach a. This part will be h of t once we reach a. And until we reach a, this part is 0. And this part is 0, so then we just have the function g of t, which is exactly what this describes. So it is the same function, but the definition isn't this piecewise type definition, it's all in one line. And let's look at another one here. Let's try this one. Use the unit step function to define the piecewise function. F of t is 0 from t going from 0 to a. G of t if a is between t, or if t is between a and b, and 0 again once t gets bigger than b. A lot of electrical things happen like that. Like it's switched on for a certain period of time and then switched back on again, or off again. So that should be interesting. Let's look at that one.
Live long and prosper.
I plan on it. So let's see, that we would have g of t times u of t minus a, because this will only be 1 when we finally reach a. So it'll be 0 up until the point where we reach a, and then this will turn into a 1. But then once we reach b, this 1 minus this 1 will be 0. So it'll be g of t times 0. So that was actually kind of an easy one. So look at that, think your way through that. And this is probably not something you're used to doing, but I guess we'll get into that. And hopefully that will be good.
Aye, sir.